The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome back, guys. In this video, we're going to be solving this very problem. Now, we're asked to find the Fourier sine series. Now, if we need a sine series, it means we're only going to be having sine terms. So the only thing we need to find is b sub n. So b sub n is 2 over pi, integral from 0 to pi, f of x sine nx. So that's our b sub n. That's what our b sub n will be. Now, in this case, our f of x will be having two values. So we need to break our integral down. We need to break our integral down. So we're going to say our integral will be from 0 to pi over 2 and pi over 2 to pi. So this will be 2 over pi. Then we have the integral from 0 to pi over 2. Now f of x here is 1. So this will be 1 sine nx. So that's what we have. And this is just the only one we're going to be having. I'm not going to write this one. It's going to be a waste of my time. Because the integral from pi over 2 to pi, when the function is 0, it's unnecessary. Because when I integrate 0, I'll still get 0. So there's no need for me to write it because the function value was 0. So I can just keep that. There's supposed to be a dx here. All right. So 1 times anything is that same thing. So that means I'll be having 2 over pi. Open up a bracket. When you integrate sine, you will get minus cosine. Then you put your nx divided by, when you differentiate this ns, you will get n. So you need to divide by that very n. And this is from 0 to pi over 2. That's from 0 to pi over 2. Now the minus is a constant, the over n is a constant. So you can come outside. So when this minus comes out, this will be minus 2 over pi times n is n pi. And then what will be left will be cos nx from 0 to pi over 2. That's what we have. Now next, this will become minus 2 over n pi, minus 2 over n pi. Then anywhere we see s, we're going to be putting the pi over 2 and 0. So this will be cos n pi over 2 minus cos 0. That's what we're going to be having. Okay. So this is minus 2 over n pi into, now there's a behavior, this has a behavior. But let me leave it like this first. Cos n pi over 2 minus 1. I can decide to leave it like that. So for a start, we have cos n pi over 2. So cos n pi over 2 is equal, when n is odd, is equal to 0. So for all odd values, you'll be getting 0. I've kind of dealt with this function before, so I kind of understand how it's going to be. You could check out my old videos where I explained it. So, because whenever n is odd, this thing here will be giving you 0. Very, very important. Then next, when n is even, such that it's following 2, 6, 6 plus 4, that's 10. 10 plus 4, 14. So that this cos n pi over 2 will be giving us minus 1. Then when n is 4, 8, 12, 16, cos n pi over 2 will be giving us 1. So it kind of behaves like that. All right, so let's see. So this is the brackets that we have. Okay, so this is what we have. Now what I'm going to do next is, let me do something beautiful. To make everything fine. This guy here, I want to turn it around. So I want to use this minus here to turn this around. So this will then become 2 over n pi into, now 1 minus cos n pi over 2. Yeah, this is what it's going to be. So this is what I'm trying to say. So I use this minus here to open up this bracket. So minus times this minus 1 will give us plus 1. Then minus times this will give us minus cos n pi over 2. So leave the answer like this. Now the Fourier series f of x will then become the sum from n equal to 1 to infinity of b sub n sine nx. So this will be the sum from n equal to 1 to infinity. B sub n is this value here, 2 over n pi into 1 minus cos n pi over 2. And then sine nx. So this is what our Fourier series would be. But there are some constants. The 2 over pi here is a constant. So let's bring it out. So this is 2 over pi. Then the sum from n equal to 1 to infinity. If the 2 over pi goes away, 1 over n will be remaining. Into 1 minus cos n pi over 2 sine nx. So this is a simplified version of our Fourier series. Now what we're going to do next, is let us impute some numbers. So let's say n is equal to 1, for example. Let's say n is equal to 1. So let's bring out some expansion here. So this will be 2 over pi, open bracket. Now let n equal to 1. What do you think will happen? Now, when n is equal to 1, I like starting with this bracket. When n is equal to 1, so that's an odd number. So this will be giving us 0. So if n is 1, we're going to have 1 minus 0, which is 1. So that means this will now become 1 over 1, 1 sine 1x. So everything here will just give us sine x. It's kind of easy. I believe you agree. It's kind of easy. So this is 1 over 1, 1 minus 0, sine 1x. 1 minus 0 is 1. 1 over 1 is 1. So 1 times 1 times sine 1x is sine x. Next is when n is 2. When n is 2. So that's even. This is 2 here. So the value of this is minus 1. So if you have this as minus 1, 1 minus minus 1. That's 1 plus 1. So that's 2. So this will give us 2. So right now this is positive. This is positive. So this will be plus. If this is 2 and your n is 2, so you have 1 over 2 outside. These 2 will cancel out these 2. Yeah, it's going to cancel out the 2. So what will be left is sine 2x. That's kind of beautiful. That's kind of beautiful. Then next, when n is 3, this part is giving us 0. This part is giving us 0. So because that's odd, that's an odd number. So this will be 1 over 3 times, if this is 0, this is 0. 1 minus 0 is 1. And this is 1 over 3. So 1 over 3 times 1 is still 1 over 3. Then sine 3x. Then next will be 4. So when n is 4, we're getting 1 here. So 1 minus 1 is 0. So everything here will just be 0 when n is 4. So there'll be no 4. Let's go on to 5. When n is 5, this is odd. That's odd. So this is 0 when n is 5. So 1 minus 0 is still 1. So 1 times 1 over 5. So this will be plus 1 over 5 sine 5x. I don't want to do everything. So this will be the final answer to the equation. Now basically, you could still say, before you get to this part, using this expression, you could say, well, let me look for B1, B2, B3, B4, so that you just have to put your values here. It's still the same thing. So this will be all for this very video. I'll see you in the next one. Bye.